Chain and sprocket ratios. Just like gear ratios and belt and pulley ratios, chain and sprocket ratios, well, quite frankly, just the same. There's no official name for this, like gear ratio has a name, gear ratio. A belt and pulley doesn't have an official name. I called it the pulley ratio. So let's call this the sprocket chain ratio, or chain sprocket ratio, whichever. Simply take the number of teeth on the driven sprocket divided by the number of teeth on the driver sprocket, or the effort and resistance. This being resistance, this being effort. That will be equal to the diameter of the driven sprocket divided by the diameter of the driver sprocket, which in turn will be equal to the torque of the out divided by the torque of the in. These ratios are identical. They're not different than gear ratio and belt and pulley. Belt and pulley's only difference is it doesn't have teeth. Everything else is identical in the same order. And then the angular velocity, this is the one that is upside down compared to the other ones. Angular velocity of the in over out. Once again, in is driver, which is the effort. Out is driven. Which is the resistance. Let's draw a picture of a sprocket and chain system. Here's a sprocket. Let's say its diameter is 1.5 inches. Let's also say that this sprocket is the driver. Let's say that this is rotating clockwise at 90 RPM. Let's say that the torque is 60 foot-pounds, and the number of teeth, let's say, is 11. Let's say that we have a chain coming from this. Dashed represents the chain. And that goes to this larger sprocket with a diameter of 3 inches. This, of course, is what's being driven out. Its RPM, it's 45. Its torque, it's 120 foot-pounds. And its number of teeth, let's say, is 22. According to the chain and sprocket ratios that we just looked at, chain sprocket ratio, or I just spelled sprocket with a P instead of an S. That is embarrassing. Chain sprocket or sprocket chain ratios. We take the number of teeth on the out divided by the number of teeth on the in, which is always going to be equal to. Always meaning not in reality, but on paper, because we are assuming on paper that there is no friction. That's going to equal the diameter out divided by the diameter in, which in turn is going to be equal to the torque out over the torque in, which in turn is equal to the angular velocity of in over the angular velocity of out. Once again, this last one is upside down compared to the others. Number of teeth out is 22. Number of teeth in, 11. Diameter of out is 3 inches. Diameter of the in sprocket is 1.5. Torque of the out is 120 foot-pounds. Torque of the in is 60 foot-pounds. And then the angular velocity of the in is 90 RPM. Angular velocity of the out is 45 RPM. What you will notice is each of these 4 fractions all reduce to the same thing, 2. Chain and sprocket ratio here is 2.